Well, guess what we're going to talk about today, folks? Little hint on the screen. I don't know. I think maybe we'll talk about the effects of the recent political discussions on television and how they're going to impact your life. Or maybe we're going to talk about slope. So I'm thinking it's going to be slope today, and we'll leave the other stuff, which is really not that interesting anyway, for another time. So slope formula. I'm hoping this is something you remember very well from algebra because it's pretty important. It's something that we looked at a lot in algebra, and it's a pretty straightforward formula, change in y over change in x, y2 minus y1 over x2 minus x1. If you don't have this formula completely engraved in your permanent memory, get it there because it's, like I say, it's pretty important. It's one we use a lot. And it's what we're going to talk about today when we're talking about parallel and perpendicular lines, because we're going to move this discussion of parallel and perpendicular lines into the coordinate plane. And the way we determine whether things are parallel or perpendicular in the coordinate plane is via slope. Just to do one very quick example calculation, if point A, try that again, there A is say at 3, -5, and point B is at -7, -2, the slope of AB, of line AB, is going to be change in y over change in x. Now, again, like the other formulas, we don't really have to get hung up on which one is x1 and which one is x2. It doesn't matter. We just have to be consistent. Once we pick one as y2, if I pick -5 as y2, then -3 has to be x2, or +3 has to be x2, minus, and again, y over x, -2 and 7. And we just do the arithmetic. Minus and negative becomes plus positive. -5 plus 2 is -3. 3 over -7 is -4. The negative over negative becomes a positive. The slope of that line is 3/4. Rise over run, slope of the line. Pretty simple calculation. So how do we use it in geometry? Well, very simply, if two lines have the same slope, they're parallel. So critical value here, same slope, parallel lines, very simple. If two non-vertical lines are perpendicular, if and only if the product of their slopes is -1. Now, the way that we've talked about this probably in algebra more than in geometry here, the way we tend to talk about slopes that way is we say if the slope of one is n, the slope of the other one is -1 over n. It's a negative reciprocal of the first slope. And if you multiply those together, you get a product of -1. That's how we tell they're perpendicular. Notice here there are a couple caveats that are listed, or a couple exceptions. Vertical lines. Why are vertical lines separate when it comes to parallel lines? Because vertical lines don't have a slope. Okay, the slope is undefined because the change in y over change in x, the change in x part is 0. That's undefined. Any two vertical lines, however, are parallel, and the reciprocal of a slope of 0 is undefined. So therefore, vertical lines are perpendicular to horizontal lines. So determine which lines are parallel, which lines are perpendicular, if any. How are we going to do it? We're going to find the slope of each line. Okay? And we're going to label what we're doing. We're going to very carefully, we're not just going to throw formulas out there and throw numbers in without telling the person reading the work what it is they're doing. So I'm going to stick with the color coding we have here. And so let's start with the slope of A. The slope of A, and again, it doesn't matter what we choose second, what we choose first. I'm going to use the formula to show this, not just counting boxes. The slope would be 3 minus 2, change in y over change in x, 0 minus -3. That's 1/3. And so we'll find the slope of B. By the way, I'm going to abbreviate slope M for line B. So the measure, and I can use a line symbol there if I want, the slope of line B, or m of line B. And again, we're going to do the same thing, change in y, 0 minus negative 1, or change in x, 2 minus 0, which is going to be a slope of 1/2. Slope of line C, again, it's -4 minus -5 over 1 minus -1. Minus a negative becomes plus positive, so that's 1/2. Aha! B is parallel to C. We've just figured that out. They have the same slope. And finally, if we go to line D, okay, so, and my points here on D are right here, here, and here. So 2 minus 0 over -3 minus -2, which is 2 over -1, or -2. And -2 times 1/2 is 1. So therefore, D is perpendicular to B, and D is perpendicular to C. The odd one out there in this case is line A. Not interesting at all. So we can get this slope relatively quickly using our formula and determine whether the lines are parallel or perpendicular. Again, same basic thing here, determining whether lines are parallel or perpendicular, using the slope. When we're given this in box format, we can also do the visual way of calculating slope, although I prefer to see the equations. But as long as we're slope of A equals, we can show it to rise 1, 2, 3, 4 over run of 2. So 4 over 2, which is a slope of 2. Okay, and then for B, it's rise of 1, 2, 3, 4 over 2. A is parallel to B, we've got that. C, rise of 1, 2, 3 over 1. And finally, the slope of D is a rise of, and I got to pick my 2 points, here we go. This rise is 1, and we go left 3. So -1/3. So C is perpendicular to D, and A is parallel to B. The downside of not using the formula is if you count wrong or somehow you mess up your boxes as you're counting, there's really no work to back up the fact of how you calculated that slope. So if you make a little mistake, you're pretty much out of luck when it comes to partial credit. At least plotting out the dots there in the different colors helps me kind of see what's going on. But I strongly encourage you to, when you're doing this in your homework, please use the formula format. You're going to do a much better job. You're going to make fewer mistakes, and we can see where your mistakes are coming from rather than just looking at a number and going, where'd that happen? So I prefer that you go ahead and use this. You can use the counting as a backup method, but let's go ahead and show our work as we're doing these. All right. I believe that is all for today. No, I'm sorry. One more. I lied. I apologize. Write the equation of a line passing through the point -1, 1 that is parallel to the line y equals 2 minus 3x. We're going to spend a lot more time on this sort of thing tomorrow, but it's a good start to kind of get going here. Because remember, when we write the equation of a line, we have a couple different ways of doing this. We can use slope-intercept form, or we can use what's called point-slope form. The interesting thing and the useful thing about point-slope form is that that's really just a formula for slope. Because if I divide through both sides of these by x minus x1, I get the formula y minus y1 equals x minus x1 over x minus x1 equals m. That's the formula for slope. I mean, I just put a 2 on that x and y subscript. And I've got the exact formula for slope. So point slope form is probably the preferred way of doing this. And how do we do this? Pretty easily, really, what it comes down to it. This is your x1, this is your y1. We're going to substitute those numbers in. So y minus 1 equals slope x minus negative 1, so x plus 1. It has to be parallel to this line, and the slope of this line is given as 2. So same slope. And we just distribute. And combine terms. There's the equation of my line. Y equals 2x plus 3 is parallel to y equals 2x minus 3. So we need to know the point. We need to know a slope. We're given the point. We can read the slope out of the other equation because it's in slope-intercept form, where m is the slope. We can very quickly find the equation. Like I said, we're going to spend a lot more time on that sort of thing tomorrow. So that's it for today. Good luck with your evening. I will see you in class.